third unit. We're talking triangles throughout this unit. So our first unit was basics, second unit was parallel lines and angles, and now we're talking about triangles. So let's go ahead and go through this. This first lesson should be some things you already know or you've learned before in elementary school and middle school, because you know what a triangle is. Triangles are a shape that have 3 sides and 3 angles. What? That's what tri means, 3. Pretty obvious. You don't need to copy that down if you don't want to, because you should know that. But we can classify a triangle. Remember that classification means describing something. Yeah, so we can describe a triangle. We can classify it by its sides and by its angles. So every triangle, we can actually describe it in 2 words. 1 word for its sides, 1 word for its angles. And here's a table you're going to want to copy down to have in your notes for the classifications of triangles. So equilateral, what this means is all 3 sides are congruent, equal, right? That's why it's called equa, for equal. The way you would see this in a picture, remember that we haven't done this much, but the congruent signs for segments is a little dash through each side. Let me make sure I got my marker on. There we go. If you see this picture with a little dash, what this means is those 3 sides are congruent. That symbol, a little tick mark, tells us which sides are congruent. That tells us all 3 are the same. The next one we have is isosceles, which is only 2 sides are congruent. So it's like a big, skinny, triangle. And how we would mark this again is that these 2 sides are the congruent ones. So because there's no marking on that little short stubby side, that means that side is not the same as the others. Only the sides that have that marking are the same. And lastly, we have scalene, which means no sides are congruent. So you might see it like this. If you see a picture like that, that means none of the sides are the same. We can't assume, even if it might look like, those could be the same. No. You might also see it like this. I might have 1 dash through this side, 2 dashes through this side, and then 3 dashes through this side. Because all of those sides have a different number of dashes, that means they are all different. Only a side with 1 dash would be equal to this one. This side is only equal to anything that has 2 dashes, so forth and so on. Because these dashes are all different, they're all different. So those are the only 3 classification by sides. However, we can also classify by angles. So again, every triangle, we can say it is this by its sides and this by its angles. So the first one is equiangular. All 3 angles are congruent. So equilateral is for the sides. We say equiangular or equiangular for the angles. Angular, duh. So again, the way we'd mark this, when I have angles that are congruent, I mark this with a single curve in the picture. Since all of those have 1 single curve, 1 rainbow, those 3 are equal. Then we can also have an acute triangle where all angles are less than 90 degrees. So a picture like this, remember 90 degrees is here. If we look at all 3 of these angles, they're all less than a full corner, right? So this would be a possible acute triangle, something like maybe if we said, let's see if I can do this as an example here, 60 and then 35 and then 85 as an example. That is an acute triangle, 60, 35, 85, because all are less than 90. Okay, obtuse, 1 angle is greater than 90 degrees. We're going to talk about why only 1 angle can be greater than 90. Acute, all of them are less than 90. Obtuse, only 1 is greater than 90. So like this one right here we can see is obtuse. You remember these classifications? Bigger than 90. So maybe this is like 110. Maybe. Could be 120. Could be 91. Could be 90.5. That's obtuse, greater than 90. And again, these are going to end up being less than 90, but we'll talk about that later. The last angle classification. So we have 3 classifications by sides and 4 classifications by angles. A right triangle means it has a right angle. So this would be our right angle. Remember that box means it's a right angle, which has how many degrees is a right angle? 90. So one of the angles equals 90 degrees. So these are the classifications. Again, every triangle we can describe in 2 ways, by its sides and by its angle. So we're going to have 2 answers for each of these. One is going to be by its angles, one is going to be by its sides. So let's look at its sides. I've got these 2 marked right here, and this one's not marked. So what this means is these 2 sides are congruent. Look back to your notes. Look at the classification by sides. Which one has 2 sides congruent? Isosceles. I always spell isosceles wrong. I think that's right. This is an isosceles triangle because it has 2 sides congruent. Now let's look at its angles. There's something special we should notice about its angle here. We got a little marking. This tells us to classify this triangle as what by its angles? This is a right triangle because it has a right angle. So we could call this an isosceles right triangle or a right isosceles triangle. It'll work out either way. Let's try again. So classifying this by its sides, notice we don't have any markings. It does not matter what the picture looks like. We don't have any markings on the sides. So look at your notes. This means none of the sides are the same. What would we classify this as? Scalene. A scalene triangle has none of the sides the same. Now let's look to its angles. Well, I don't know what these 2 angles are, but this one's 130. That's bigger than 90 degrees. What type of triangle has an angle bigger than 90? Obtuse. So we could call this a scalene obtuse triangle or an obtuse scalene triangle, same thing. Okay, I want you guys to try this one entirely by yourself, and then we'll check. What do we think for by its sides? Look at the markings. What do we think by its angles? Look at the labels. Go ahead, try it. Okay, so this one is congruent, congruent, congruent. This is equilateral by its sides. All 3 sides are the same, as well as 60 degrees, 60 degrees, 60 degrees. This is also equiangular because all 3 angles are the same. Little hint here, guys, and something to make a note of, actually. An equilateral triangle will be equiangular. Those 2 go together. They don't go with anything else. Those 2 will always go together. If it's equilateral, it's guaranteed to be equiangular, and vice versa. Okay, let's add on something else now. Now, the angles in every single triangle, regardless of size or classification, if it's a right, if it's an acute, if it's a scalene, doesn't matter, will always add up to 180 degrees. 180 degrees is very special. Yeah. And some of you guys might have known this from previous classes, from previous years in your education. All 3 angles add up to 180. Now, knowing this fact, if we know 2 angles in one triangle, we would be able to find the third, because we would just need to figure out how much more do I need to get me to 180. Let's go ahead and look at this. So we're trying to find the measure of angle B. So what I know is angle A plus angle B plus angle C equals 180. I know for sure, guaranteed, all 3 angles in a triangle add to 180. And I do know 2 of them. I do know 2 of them. We know A is 20 degrees. We're trying to find angle B. And we do know C. What degrees is C? 90. It's a right angle. So even though I don't see a number, I know it's 90 degrees because of the marking. So all we have to do is solve this for angle B. I'm going to go ahead and add these together. That's going to be angle B plus 110 equals 180. I'm going to subtract the 110 over. This means angle B has to equal 70 degrees. 70 plus 20 plus 90, you can try it in your calculator if you don't trust me, is going to equal 180. Go ahead and try it on this one. We know two of the angles, we want to find the third one. Go ahead and try it. They all add up together to equal 180. Okay, so you should have done something like this. 93 plus 32 plus, I'm going to call this x. If we're trying to find something that they don't give you a variable for, you can always put it in. Okay, they add up to 180, so I'm going to add these two together. 93 plus 32, that's 125. And now that I'm moving across an equal sign, now I need to do the opposite. Subtract 125. We get x equals, this should be 55. I think I did that right. So again, all three add up to equal 180. Really what we're doing is adding the two we know and then subtracting over to the other side. Let's make it a little bit harder now. We want to find the measure of angle S. Now this is something you want to kind of have in your notes. But if you look at this triangle, let's classify it by its sides. What type of triangle is this classified by its sides? We have two congruent sides. This is an isosceles triangle. There's something extra we know about isosceles triangles, about their angles. When we have an isosceles triangle, we have what are called the base angles here. Those are going to be equal as well. We call these base angles. If I have my two sides like this, the two angles at the bottom of those congruent sides are going to be equal. So like if I flipped this, and here are my congruent sides, these are my base angles at the ends of my two congruent sides. So because this is an isosceles triangle, we know that if this is 20 degrees, this is also 20 degrees. So now we're good. Now we have two angles. We need to find the third. Go ahead and try now to find the measure of angle S. So we know that angle R plus angle S plus angle T equals 180. I know R and T are 20. I'm going to add these together and I get 40 plus angle S equals 180. Subtract 40. We should get that angle S equals 140. 20 plus 140 would give us the 180. So this is an important concept to remember. If I have two sides congruent in a triangle, you will have these two angles congruent as well. Okay, let's look at this one now. We want to find the measure of angle C. Now, looking at this one, classifying it by its sides, what do we know about how we classify this by its sides? This is an equilateral triangle. Now, equilateral triangles are once again also equiangular. We just said that. It has to be both at the same time. These can't go with anything else. Sorry, equiangular. So what that means is all three of these have to be equal and they have to add up to 180. Think for a second about how you could solve for one of the angles then, what they each have to be. We would actually take 180 and divide it by 3 because each of these are the same. So I'm splitting 180 up evenly between all three of them. So that is 60 degrees. Each of these angles is going to be 60. Even though they're only asking for angle C, they're all going to be 60. Little hint here again. An equiangular triangle, all the angles will always be 60 degrees. Those things have to go hand in hand. Now let's try it with this last one. Now this is an isosceles triangle. So remember what we know about isosceles triangles. They also have their base angles congruent. These are the same. This is a bit of a challenge now. Think about, go ahead and try it, what X and W would have to equal. They're going to equal the same thing. What would they have to equal so that everything adds up to 180? We've got 80 degrees so far. Think about how many degrees are left over to be split between those two angles. Go ahead and try it. Okay, so here's how we can look at this. If all three of these add up to be 180, that means I've got angle X plus angle W plus angle V equals 180. Angle V we know is 80 degrees. So if I were to subtract that over, I've got angle X plus angle W equals 100. Now let's think. If X and W have to be equal and they have to add to 100, what do you think they both have to be? 50 degrees. 50 degrees plus 50 degrees would give us 100. So that is our answer. They both need to equal 50 degrees. You could just do 100 divided by 2. If you weren't sure what half of something was, like if it was like 72 and you're like, ooh, I don't know what half of that is, divide it by 2. We have one more level of difficulty here and then we're done. So a little bit harder now. So we're dealing with equations. This is always the highest level of difficulty, is now we have to deal with equations. So this is still true, that angle A plus angle B plus angle C equals 180. We're basing it off of this fact. Angle A is 5x. Always a good idea to label our picture. And angle B is 2x plus 10. So I'm going to add these three angles once again. What degree is that? 90, it's the right angle. I'm going to add these three angles together, set it equal to 180 and solve. Angle A is 5x. Angle B is a full 2x plus 10. Angle C is 90 equals 180. Take a second to try and solve that. Okay, let's check. Because again, sometimes we struggle with, even though we have the equations correct, we can't solve it. Combine like terms. 5x plus 2x is 7x. 10 plus 90 is 100 equals 180. You should subtract 100 over. This is going to give us a decimal, I believe. This isn't going to come out evenly. Divided by 7. I'm going to go ahead and leave it like that, 80 over 7. But as a decimal, oops, that is 11. X equals 11. 0.4, something like that. And we solved for what they wanted us to. Remember, if you solve for X, you always need to go back and check that they actually solved for, that we actually solved for, excuse me, what they were asking for. They asked for X, so we're done. Okay, you guys are gonna try this one now. So label in the picture, here's our three angles. They add up to 180, and then find the measure of angle T. Go ahead and try the entire question, finishing off by solving for T. Okay, here's what we should have done. They add up to 180. Here's all of my angles. They add up. 3x minus 10 plus 20 plus 5x plus 4 to 180. I'm going to go ahead and combine some like terms. Let's see. I've got 3x and 5x is 8x. I've got a negative 10. Be careful, guys. The signs, you need them. A positive 20 and a positive 4. You should get a positive 14. Try it in your calculator. Negative 10 plus 20 plus 4. That's a positive 14. I'm going to subtract the 14. We got 8x equals 180 minus 14. Whoops, 166. And again, I don't think this is going to come out evenly. We divide by 8. X equals, I'm going to go ahead and get this as a decimal for a reason, 20.75. Then we are good geometry students. We reread the question and we go, wait, I need to solve for T and I only have X. I'm not done yet. Here's T. Angle T is 5x plus 4, and there's our X. Let's plug it in. plus 4. I'm going to go ahead and use my calculator. 5, clear. 5 times 20.75 plus 4. We should get 107.75. Okay, with this, guys, that's actually as hard as it gets for your assignment. So from here, you are able to go straight to your assignment. Hopefully, you are catching on okay. Go ahead and give it a shot on your own now.